Wow, thanks for coming this morning. It's been an amazing GTC. I hope you're enjoying the nice air-conditioned room, comfortable seats. This is a great place to be. I want to start off, we're talking here about AI agents and these amazing assistants that are going to help us be more productive and get our work done faster so we can do even more. But I wanted to start with just a simple human touch. For those of you who haven't been to the gear store, inside the convention center, one of the things they're selling is these amazing t-shirts. Each GTC, we do a shirt that kind of diagrams out the conference and the place that we're at. And Lisa Burns designed this shirt. This is made by a real artist, and they're spectacular. Lisa was signing these at the gear store, and I thought this was really cool. My daughter talks to me a lot. She's an artist, and she says, "Dad, is like AI gonna like put all artists away?" I'm like, "No, AI is gonna give artists amazing tools." But I know she'll like that this was 100% human. Before we kick this off, I wanted to ask all of you. I know this is the Agentic AI 101 session. How many of you use some AI assistant, AI tool regularly, like on a daily basis? Is it? All right. Most hands went up. This is cool. Yeah, you're at GTC, so I think that's fair. But what I wanted to mention was that even here in the US, only about 16% of the kind of adult population uses some AI tool right now on a regular basis. So, as you're interacting with your colleagues, especially in your work environment, these tools are amazing assistants for all of us. Some are afraid to use some of these tools, but the best way to start is literally just jump in 2 feet first. And the way you interact with most of these tools is pure human. You just talk to it like you're talking to a friend or a coworker or a family member. So, as you leave GTC and you go back into the real world, motivate those around you to just give it a shot and try it out. So, one thing I did, just as examples of using AI assistants, one thing that I did was I loaded my presentation into my personal assistant that I built for myself. And I asked it, okay, so in this presentation, about what time will the audience get bored and fall asleep? And it said around slide 26. So I trimmed it back to 15 slides. So let's see how it goes. So, AI is rapidly evolving. It was just a few years ago that the kind of big bang of modern AI happened, and we all had access to ChatGPT, where not only could we ask it questions and it gave us a quick response, but we could ask follow-up questions and we can have a conversation just like we have with our peers and our friends. And we've been using these tools for some time now, and it was just a year ago that another amazing thing happened. Actually, it was when OpenAI released the o1 model, and AI could start reasoning, where AI could take a problem or a prompt, break it down, think about it, create a plan of how it would work through this challenge, work it, evaluate its answer, and give you back a response. It would take a little bit longer, it would generate a lot more tokens, but it would give you an answer that was way more helpful or way more valuable. That was only a year ago, and then DeepSeek took reasoning and put it into their large language model and opened it up for the world, and it really changed everything. And a lot of what we're seeing now in Agentic AI is based on the ability that these AI models can reason. And then it was just, it feels like just a month ago, where things are changing again, where the OpenClaw project was announced and made available to everybody. And now we're feeling essentially AI not just help us out and give us answers and information, but actually do work for us. These more autonomous, long-running, self-evolving agents. So we'll walk through a lot of this in the talk today. So I talked about OpenClaw, and just to give you a perspective, Jensen did a video. How many of you watched the keynote or went to the keynote? Awesome. The keynote's always a ton of fun. Not only is it a lot of fun, you learn a lot. One of the things Jensen showed in his keynote was a really fun video on the impact of what we're seeing with Agentic AI today, and essentially created a video of this chart. And you look at how the impact that projects like Linux, for example, I mean, Linux has essentially been the underpinnings of the digital economy. And then you have projects like React. I mean, the mobile web or the mobile internet has also changed the way that we, not only the way that we work, but the way that we interact with the rest of society. And you see how those projects grew, and look at how the Open Cloud project has grown so far, just amongst the developer community. Some thinks it's like a bug, but it's not. That's actually like a straight vertical line. And it's gonna be amazing to see where it goes. It's gonna allow not just developers to build new amazing applications and tools and things that are going to help us out, but it's also gonna enable us to even get more engaged with this AI technology and building personal assistants and things that will help us as individuals. But a lot of people think, well, as AI is evolving really quickly, that we're just, everything's changing and we can't keep up with it, and oh my gosh, I got to learn a new thing. But the reality is that these different types of AI are going to stick around. We're not going to just have one type of AI that is going to help us be more efficient, help us do more work. Sometimes you just need a chat bot that you can ask a simple question, and really fast, near instantaneously, it will give you an answer that you need. And we still need those. You don't want to ask it a super simple question like, hey, what's the weather today? And then 10 minutes later, it comes back to you with a really long, crazy answer. No, you just want it to tell you what the weather is today. But then sometimes you want these chat bots to be able to, like we talked about with what DeepSeek is able to do with reasoning, to be able to break the problem down and think a little bit deeper. Sometimes you want these AI agents to help you do really hard things like assistance. The world of software programming has completely changed now with AI agents that can code, that can write code, that can review code. It's changed the industry of software development. The same when it comes to researching. I mean, research, I'm sure we've all done this. Sometimes we've had a topic we want to learn about, whether it is just for personal education or we need to research a topic for our job, and we go away and we spend days or weeks researching a topic. Now when AI has access to all the information essentially in the public sphere, and also has a lot of the information that you've given it in your private environment, it can do amazing deep research projects for you, and in a matter of minutes can give you a report that could have taken you weeks to do. Agents now are going to start evolving on their own. We're starting to see this, especially with these OpenClaw examples, where agents not only are using the kind of tools and skills that it inherently has access to, but if it can't figure out the problem, it will code up a new ability to do something and try and figure it out on its own. And then lastly, we're seeing agents work with agents. So a multi-agent system solving problems, just like we work with our teammates and our coworkers to get hard problems done. Agents are going to start working with other agents. So then it's like, well, how does an agent work? I know a lot of you, especially if you haven't gotten deep into the way that agents work, you think that, oh, okay, an agent is a amazing AI model like GPT or Claude, and it has a UI wrapped around it, so it has a human-like interface, and you ask the model a question, the model responds. But the reality is an AI agent is much more complex than that. And an AI agent kind of works like how a computer works. So an AI agent takes in a prompt, and now it's not just asking it a question. You can give it all types of information. You can give it text. You can give it images. You can give it video. You can give it scientific models. You can give it all kinds of things, and it can work with this information. AI agents now have memory. We see this as we work with like ChatGPT and Claude and Perplexity and other tools, where sometimes we'll come back and we'll ask a question that's somewhat related to something we were maybe asking it 2 weeks ago, and it remembers that. That's because these agents now have longer-term memory. Agents for a little while have had short-term memory. Now they have even longer-term memory. So that requires a lot of infrastructure in the back to be able to retain and understand the context of interacting with you and personalization. Agents are also a system of models. It's not just one large language model sitting inside that agent. That agent has models that maybe understand your speech input. It has models that understand your intent. It can route information properly. Obviously, it has large language models. It has models that understand images and charts. Many different models are used to, system models are used to operate these agents, so it can not only get you a response that is very helpful and valuable, but also do it fairly quickly. And as people are building agents now, they're learning that when they build agents with a mixture of different types of models, that they have a higher level of success. They may be using an amazing frontier class cloud model like GPT 5.2, but then they may be taking an open source model that's much smaller, doesn't have as much general intelligence, but they can customize it and specialize it for a specific thing. So when that specific thing needs to be done, the information can be routed to that model. That model could come up with a response very quickly. The overall agent becomes more accurate, is better at what it does, and it's faster, so better response time for the user. So we're like, hey, this feels a lot better. And also drives down cost by running that model, let's say more locally, or just generating less tokens to get to the answer. So their system of models. We talked about agents communicating with agents. Agents will often have sub-agents. So it'll have a specialty agent, a friend that's really good at this one task. It can route questions essentially to that agent, get that information back, save that, and essentially synthesize that with other responses it gets back from other agents. Agents can have skills, and we have skills and tools. Tools are like if we're doing carpentry, being a really good carpenter, that's a skill. Having access to a hammer and a saw, those are tools that carpenter can use. So agents can be really good at things, like really good at summarizing things, really good at generating certain types of content, really good at understanding a specific domain, skills that agent has. Agents will also have access to using a computer, which is kind of cool. Just like we use a computer, literally going into a user interface and clicking around and navigating to gain information. Often, a lot of agents will be using tools like command line interfaces and APIs to get access to information, but sometimes it's good to just be able to navigate a UI just like we navigate a UI. And then access to data. Have access to structured data like databases, be able to do SQL queries on data just like we do, as well as access to unstructured data like files. Documents, PDFs, videos, and such. So it has the knowledge of the domain it's in, your organization, your company, whatever it may be. So it has that inherent knowledge. We'll be talking a little bit later about unlocking data. So that's just generally how an agent works. So has anyone been on the show floor yet? All right, a lot have not. I highly recommend today going to the show floor. I'm going to play one video demo that just shows how easy it is now to build an agent that can do amazing things. There's a little background noise, but this is real. This is right off the show floor.
All right, we are going to build a LangChain deep agent with physical wooden blocks. So let's first pick out the brain for our agent. That's the LLM. And then put it down, perfect. And we should see it in a moment. Let's refresh it. Okay, cool. So that's the brain for our agent. If we're happy with the brain, press the button. Okay, the next thing for our agent is we're going to give it some tools. These are all MCP servers, so in them are multiple tools. So pick out some tools that you want.
Let's do Telegram.
Telegram.
Okay, can I put it here?
Yep, put it there.
Okay, I'll do I love a wiki.
Wikipedia.
Okay. And then we love a weather server.
And weather. Okay. So we've got Telegram, Wikipedia, and weather. If you're happy with that, press the button. So we've got our brain, and we've got our tools as MCP servers. And the thing about deep agents is it also provides things like context window management. It provides things like to-do lists and planning, and these help our agent be better. So now we can ask it things. So we have these tools. So we could say, for example, get the weather in Santa Clara, and send it to my work chat. I have a work chat on Telegram, so we should see that first it got this current weather, then it got some updates, message right here on Telegram.
Nice.
So that was Hayden and Noel. They're doing amazing work on the show floor. I highly recommend going and experiencing this demo. What just happened essentially is the simplest form of programming and building an agent. Noelle said, okay, I want my brain to be Claude. I want to have some tools. She used Telegram and weather, and asked a simple question, said, hey, just email it to me. So not only was or text it to her, not only was the agent just answering a question, which obviously we could just ask ChatGPT to answer me a question, but not only that, it sent her the weather. And then you can just automate that. Say, hey, feed this information to me, every morning at 6 a.m. when I wake up. And just the simplest form of building an agent. What's really cool in this demo is that agent that Noelle built there, Hayden would give her a block, has a little QR code on it. That QR code essentially takes you to a GitHub repository with the code for that agent, so Noelle can leave GTC and keep building her agent. So it really is simple. I highly recommend when you want to get going, just jump in 2 feet first. You're going to learn a lot. It doesn't mean that you're going to get it right the first time, but you'll learn, and then you can tear it down and keep rebuilding, and it's amazing how far you'll get in a short period of time. One thing we do at NVIDIA is that we build blueprints and examples for our developers to quickly get going. And some are more complex, like the example that you saw with Hayden and Noelle. That example is a very simple example. The example on the screen is a little bit more complex. This is building a deep research agent. So this is an agent that can answer questions for you based on your data, based on the information across the internet, and it can also do deep research, meaning it can work to give you the information over a longer period of time, give you a much longer, more complex research report. And as you see here, just quickly what's happening here is that the user is asking a question. Sometimes the question's simple and it can give you a quick answer. It goes through an intent router and either routes you essentially into the deep research agent or routes you down into the shallow research. Shallow research, it'll just quickly give you an answer. But if it goes off into the deep research agent, it'll then go into an orchestrator. This is an example of agents working with agents. The orchestrator will figure out what the user wants. It may use a much larger model that has like frontier level intelligence. In this case, it's GPT-5.2, and it'll figure out what it wants, and then it'll send off information to a bunch of workers to go help out. And those workers they have different specialties. Some will be good at searching the web, while others will be good at retrieving information locally from a data repository, for example. Some will be better at processing images, and it'll get all these sub-agents going, and then that information will keep coming back into the orchestrator, and the orchestrator will organize that information. If it needs more, it will send out additional requests, and that'll just keep going. And these agents will use all the tools at their disposal to get a great answer. So it's an example of a fairly complex agent. And what agents like this also are able to achieve, like we talked about, is by using different types of models for different use cases, customizing models, taking a model, taking some data, curating that data that may be specific to a domain or specific to a skill, infusing that, essentially teaching that model of how to do that thing really well with that data, making it even more accurate, making it even more efficient, helps the overall application. So we post these blueprints on our website at build.nvidia.com. You can use them in whole, you can use them to learn, you can take bits and pieces from them as you're building your own application. But essentially, we're building these applications for ourselves, and then we're opening them up and giving them away to the entire community. So as we learn in NVIDIA, as we learn with our partners, we're opening that up to help the entire developer ecosystem, make progress. We're all in this together. We're all learning together. What's really cool about this is that our team, and these are some of the best developers, best data scientists in the world, that took this blueprint, built a deep researcher, entered in kind of a few competitions that are tracked on a few different leaderboards, and you can see building a deep research agent with this open blueprint has led them to the top of the leaderboard, which is super exciting. We're very proud of the team, but this is all available to you. So you can go use services out there. You can also build your own AI when you need something that is a little more custom. And I'm going to show you one example right now from our great friends over at ServiceNow that have built a multi-agent system to help automatically close and deal with customer service tickets. Because we all know sometimes we have to call customer service, or we have to chat with an agent, or we have to submit a ticket. Sometimes we don't always get the quick response that we'd like, but ServiceNow is making amazing progress on this.
A new wave of AI has arrived. AI can go beyond answering what's and how's and help do. When enterprise service operations see a spike in ticket volumes, backlogs grow, response times slip, actual work must be accelerated. At ServiceNow, AI agents take on specific roles to handle service tickets from start to finish. Let's take a look. First, specialized agents, each with a unique skill, are set up and put to work. As tickets come in, case agents check the details and screenshots, then pass the context to NVIDIA Deep Research agents. Triage agents look through past fixes, similar cases, logs, and guides, pinpointing the issue and finding the best way to fix it. Resolution agents confirm the root cause, apply the fix, and update the case record. When escalation is required, engineers receive a fully prepared case, including analysis, logs, and recommended actions. ServiceNow agents are built on a system of models, including Cloud Frontier models, ServiceNow's April, and NVIDIA Nemotron, using the NVIDIA IQ blueprint. The data is clear. 90% of tickets are resolved by autonomous agents, freeing engineers to focus on the hardest problems.
Isn't that cool? Now that's ServiceNow. ServiceNow's team, they're amazing. They're very advanced. They've been not only building AI systems, but AI models, doing research, significant research, contributing that back to the community and helping everyone evolve AI. But it just shows you what's possible. Also, especially even in a business environment. As we're building some of these newer, advanced, self-evolving agents in prototype or for our personal use, we can move very quickly. But when it comes to rolling out an enterprise-grade agent, it has to be in compliance with all the policies of the organization and everything that the customer needs. It needs to be super secure, and there's a lot that goes into rolling out these applications. But the work that they're doing and the rest of the community is an inspiration for all of us. Okay, I want to switch to talk about a little bit about personal assistants. So, as we talk about OpenClaw and the amazing energy that project has brought to the entire developer community, even personal community. You don't have to be a developer to use OpenClaw. It's amazing how easy it is. It's just creating so much energy. We created in the park. So has anyone been in the park? Awesome, a lot of people have been in the park. So in the far back end of the park, on the left side, is a tent. And we set up a Build-A-Claw tent. It's kind of like Build-A-Bear, except for your own personal AI assistant. And it's been a lot of fun all week. It's open the rest of the day, I think until 5 p.m. I highly recommend going and checking it out. You can go there just by yourself. You can bring your device with you if you want to build your own personal assistant, build a claw on that device, and you can see some of the things that are happening there. One thing I want to call this picture in the center top, the guy teaching everyone, that's Peter Steinberger, the creator of OpenClaw. He's super excited to have this here and have all this energy around this project that he created, that now not only is everyone using but contributing to. Toy Jensen's building his own claw. Down the bottom left, that's my personal assistant. That's my DGX Spark that's sitting across my desk. cranking away for me. You don't need much. It's running headless. It has essentially, it's plugged into the wall. It's got an Ethernet jack. It has Wi-Fi built into it too if you want to use that. And it's running Nemotron 3 Super, which is one of our latest open source models that we released that provides amazing levels of intelligence. It's a larger model, 120 billion parameters, but only 12 billion are active, runs amazing on the DGX Spark, providing me all the help that I need. Even on the bottom left is a pallet of DGX Sparks that they've brought to this event because everyone's super excited and want to buy a Spark and get going themselves. So I highly recommend checking out Build a Claw. And people ask me like, well, what are you doing with this? Like, 'cause you want it to do work for you. Now, my recommendation is I'm taking baby steps because these agents want to use all the resources at their disposal to help you get certain work done. So sometimes they may go a little further than you want them to go. If you've been reading some of the posts on X or some of the stories that are out there, but the best way to learn is just to get going. So I'm personally taking baby steps. I've given my claw a name. His name is Magic. Magic Johnson was my childhood sports hero, so I thought that's fitting because the way these things work, they do sometimes feel like magic. I have it connected to Magic has his own email address, so I haven't given him my email access to my email account. He has his own email account, and so I want him to understand some of the things that are going on in my life. I just forward emails to him, and he just kind of reads those emails and takes that information in and is now an expert at whatever I send him. Read-only access to my files, not read-write. So he has the context of things that some of my files, I have 20 years of files, and so knows things about me that maybe I don't even know. Has access to my home automation system, like it does things like run my lights in my house and my sprinkler system. Has access to my home security system. So I've kind of started slow, and giving him access to a few tools, a few systems, and then he can start doing things for me. I've been using it just a lot for research, but also for things like starting to kind of alert me when things have happened, like, you left the garage door open again. Some of those things can be like if-then type things, like, okay, if it hits 9 o'clock at night, let me know if I left the garage door open. But sometimes those scenarios don't always work because my personal patterns change. But when your personal assistant starts learning your personal patterns, you don't have to have these kind of, if this happens, then do this. It'll think and it'll reason and really help you do something that's much, much more intelligent. So at NVIDIA, what are we doing about it? So we announced a project called NemoClaw this week, which is really exciting, and it's supposed to help developers keep these new types of agents, these more personal assistants, kind of contained. It's like on your left-hand side, on the left-hand side, are like these claws that are kind of a little out of control. They're having a ton of fun. They're learning new things. But you're like, what are you doing? For those of you, I have some younger kids. For those of you who have younger kids, you totally understand. And what NemoClaw will do is help the claw, the personal assistant, kind of stay contained in the sandbox. Sandboxing is inherent to OpenClaw, but they're smart little guys, and they want to break out of everything that they can to do as much as they can possibly, and so it helps them just stay within that nice, secure sandbox. So a little more detail on NemoClaw. NemoClaw essentially has one component that we're releasing as an open source project called OpenShell. It helps not just create those sandboxes, but ensures that they stay within the policies that you've defined. There's a policy engine. It even goes all the way down to the network level to ensure that these agents stay within their sandbox and do not break out. Also has a privacy router. Some things that you want this agent to do, you want that information to stay locally. You want it to execute locally. And so there's a privacy router built in where when you need it to use the local resources, use the local AI models, it'll stay local. But based on the policy, if it needs to go out to get some information, like search the web, like my agent's using the Perplexity API to search the web, I have given it that authority to go do that. So if it feels like I don't have the information locally, it'll navigate out and use the Perplexity API to get more information. So a privacy router can do that also at more of an enterprise level scale. And it's a really exciting project. We're contributing all of this work into OpenClaw, and so we're very happy to be working with that team. So this is all now available online. The teams worked really hard, really fast, and now it's available to everyone. So it's a project worth following. Another thing that I mentioned that I'm personally using, Nemotron 3 Super. It's a model we're very proud about. Our goal with Nemotron, as well as our other open source models, like Cosmos for understanding the physical world, Alpamayo to help with autonomous vehicles and self-driving. We've got models, Clara models for healthcare, and so on and so forth, BioNemo models. With Nemotron, as well as these other model families, our goal is to not just make really good models, fully open them up to the community. So the model weights are open. We try and open up as much data as possible. This enables the community to take these models and further work on them and making these models great for them. So not only are they highly accurate, and we try and make our models as efficient as possible, so it uses the underlying infrastructure as well as it could, but we try and open as much up as we can. And here on this chart, there's a new benchmark called Pinch Bench, which is rightfully named, and you could see the models right above that are all like big proprietary cloud frontier models, the leading models that we all know, Claude and GPT, and there's Nemotron 3 Super right under that. So we're extremely proud. And so when we're so proud, you see a lot of us wearing these little guys around the show. So we're all having a lot of fun with OpenClaw. And then, well, where do you run these things? Well, you can run these new types of agents everywhere. But one thing that's kind of a phenomenon is, we mostly do everything up in the cloud or in a big data center, and the personal devices have kind of faded away a little bit. Like, I felt like it was 10 years ago we all had like a NAS box or something on our desk, and it did things for us. Now everything is becoming a cloud service. Well, the personal assistants are starting to shift back to the desk again. Like I showed you my DGX Spark that's running my personal assistant. Having that locally, one, it makes it more affordable. You buy the device, and it uses all the resources of that device, and it doesn't run up a big bill, which is kind of nice and helps. Also, it's sitting right there. If it's not behaving properly, I can go, slap it around a little bit. I can unplug it, and that's actually kind of nice. And so DGX Spark has been a really fun device we started shipping last year. We have a new type of device, the DGX Station. Think of the DGX Spark as like what you saw. It's this little device. It's like the size of a Mac Mini, sits on your desk. DGX Station is like the size of like a gaming computer, right? It's a workstation. It has an amazing amount of power. It's more expensive, but it can run, frontier class, trillion parameter models. You could use it as like a workstation for a team or a group. And I think some of the mindset could be like, hey, if I'm going to add to this team, maybe I'll make that investment. I'll get a device like that. It's like hiring another employee, and it'll make the whole team more and more efficient. So there's this whole new class of devices that it's worth learning about and understanding how they work, because they may fit into your into your world and your system really, really, really well. So I'll wrap up with kind of where do you begin? So I asked the question at the beginning, like how many of you are using these assistants on a regular basis? Because really the best place to start is just jumping in. A lot of us use like ChatGPT or Perplexity. Do a lot of you personally subscribe to these services versus using the free tier? Yeah, about half of you. $20 a month. It's like just sacrificing, three drinks at Starbucks a month, and you can have your own advanced AI assistant. It's not too bad. Just use the tools. Some of these I have up here are some of the more advanced tools, like Perplexity Computer. It's just spectacular. It's rolling out now to more advanced subscribers of Perplexity, but it looks like it's going to be coming to all Perplexity subscribers soon, where it has a component that's installed on your desktop, so it has access to some of your local local resources so it can do things for you using your tools on your computer. Really exciting. Same with like Claude Code and Claude Cowork that was built off of Claude Code. They're just amazing tools. I highly recommend using them. If it's at work and your IT team professionals are saying like, no, you can't use them in our environment, keep pushing them. They need to say yes. We all want to use these tools. We want to help them do our job better, be more effective at what we're doing. Push them to use these tools because they are extremely effective. Second, I said, unlock your data. I know this sounds a little bit scary, but if you're thinking about whether it's in your work environment at home, if your AI doesn't have access to your data, well, how can it really help you in what you're trying to do? So one of the first steps to get going is just ensure that your data is available to the AI. Yes, you want it to follow the properly security policies and access controls and stuff, but it is worth processing the data and making it available to AI, whether it's structured data like a database or unstructured data like files. Unstructured data, you may put it into a retrieval augmented generation pipeline. I'd point to build.nvidia.com because just like with that IQ blueprint for building an AI agent, we have a blueprint there that also helps you build a retrieval augmented generation or RAG pipeline. There's a blueprint for that. So it starts with unlocking your data because now the AI has access to the knowledge of your organization, your business, or in the case of Clause, in our personal life. So a lot of it starts there. And the other is creating your personal assistant. Try building your own Claw. It's a ton of fun. I highly recommend taking it slow. When you install OpenClaw for the first time, it takes you into an assistant where you can answer a bunch of questions, yes or no. It's okay to say no to a bunch of them. You can start slow and then slowly learn and enable them to do more and more things. And you'll find out you'll have a extremely helpful friend sitting beside you 24/7. So when you're sleeping or you're hanging out with your friends or you're playing with your kids, your personal assistant can be doing things that you'd want it to do. So okay, so I'm gonna wrap up now with one more video from our friends at Edison Scientific, new spin out of a research lab that is doing amazing things in the area of science, creating AI scientists to take essentially 6 months of work and compact it down into an overnight effort. So, and this is going to help, things like this are going to help us solve some of the biggest challenges that we're facing in humanity. So check this out from Edison Scientific.
A new wave of AI has arrived. AI can go beyond answering what's and how's and help do. Scientific research is expensive and time-consuming. Reading papers, running analyses, testing hypotheses. Edison Scientific is building Cosmos, an AI scientist that can compress a 6-month research cycle into 1 day. Cosmos is not a single model. It's a coordinated system of agents running on NVIDIA's AI models, compute, and CUDA libraries. Customized open-source Nematron models handle specialized tasks, while cloud models provide general intelligence. It starts with a prompt to see how small genetic changes in the brain might lead to Alzheimer's. The Edison Literature Agent uses Nematron Parse to scan millions of peer-reviewed papers, patents, and clinical trial records, separating text, figures, and formulas. From there, frontier models can extract insights from decades of Alzheimer's research. The Edison Analysis Agent processes large-scale biological data, accelerated by CUDA libraries, cuML and cuDF, and interpreted by Nematron to identify statistically significant genetic patterns linked to cell loss. And finally, the Edison Molecules Agent uses a model trained with NVIDIA NeMo-RL to reason over chemical structures and propose molecules that help prevent cell loss. Edison is advancing the search to cure diseases like Alzheimer's and accelerating the pace of discovery across every domain of science.
So thank you all for coming. Enjoy the rest of the day today, final day at GTC.